All right, so the goal here, we looked at those bikes earlier, spin bikes that had the internal components. This demo is to show you how to set up internal components in SolidWorks in a way that's easier to work with. But not only that, also where to get components. So what this represents, it's similar as if an engineer gave you parts or your client gave you parts and said, okay, we want you to redesign a camera and here's what we want it to work around. So again, the camera is the suggestion, but not necessary. If you need to grab parts, simply grabcad.com. You can create an account and join for free. But depending on what it is you want to redesign, like if you're looking for a screen, you can definitely search components and find them. Or like if you want like a speaker, this is where I would go, like here you go. You can see some of these things to download components. Often what they show you is a render, but down here you can see the actual files you get. So for example, this is not a good one because to my eye it looks like it's all just PNGs. Is there a set file? There is a set file in the middle. What is also on this list here is showing you file types that SolidWorks can open, but I've highlighted 3, Parasolid, IGES, and STEP. These are the best non-SolidWorks files to import to SolidWorks. So when you're looking on GrabCAD, you'll definitely find some SolidWorks files, but more often than not, you'll probably find one of these. Those are good ones to get. So it works as advertised, search for stuff. I have gone ahead and downloaded some files for you all. And again, this is my recommendation. If you go to Box Project 4 Camera Components, I have a LiPo battery for you, a USB Type-C port that can kind of act as a representation for charging and data. So I feel like that's a kind of a 2-in-1 for realism. I grabbed a 3.5-inch screen because I don't know, some of you might have wanted a screen at the back of your camera, but not necessary. You can ignore that one. But the main camera components is right here, this Ocam 5-megapixel camera. When you download these files, they come in as zip files. I'll show you here. I already have the Ocam unpacked right here. And so I've already created a part file from it, but no, I won't delete it. But simply you would see these 4 files. You see a render of what it looks like. It actually comes with the USB labels to map on in Keyshot if you want to, which again, it's going to add to realism. And then it comes with the part file here, which if I quickly change this to details and then file extension, it's a step file. So the way you work with these files is you simply go to SolidWorks, go to Open, navigate to the file that you downloaded, and you go ahead and open up the step file. SolidWorks unpacks it. Here I think it's asking to create a new assembly for it, so I'm just going to go ahead and hit OK. That's because it's being, I believe, imported as 4 separate parts into an assembly. So certain things to look at, you can check at this point. Sometimes what I'll do is I'll just look at where it's oriented on the planes. Sometimes you'll get something that's like way off center, but you can deal with that at a later time. It's just something that I like to look at. And honestly, from this stage, you could go, I would go to File Save As, and actually the way that I would do this, I would save it as a part, just for simplicity's sake. You could save it as an assembly, but then it's going to create 4 separate parts. It's going to make an assembly for something that's like incredibly simple. So I would just simply go Save As, navigate to SolidWorks part.sldprt, and go ahead and hit Save. It's asking me about replacing it. That's fine. I mean, that's what I already did. That's how I created it the first time. And now if I close out of this, again, it's going to ask me, do I want to save it? Because I didn't save it as an assembly. If I go ahead and if I open the part here, you'll see that this is what it looks like. So this is the SolidWorks icon. It's at the bottom of the sheet there. It means imported body. So this is basically just like it's data. It's SolidWorks data. It's solid. There's something there. It just doesn't have the tree. It's as if the Photoshop forgot the history. or you flattened something in Photoshop. You flattened all the layers together, so all the data is now combined. That's essentially the analogy there. So what I would like you to have at the bare minimum, this is the main component. And again, the reason I suggested a camera, I think there's a lot of opportunity, but also the components are relatively simple. You have a PC board, you have a camera. There you have it. What I would like you to have as well is a battery, because it needs to be powered somehow. So that's where this LiPo comes in. But again, you're welcome to use your own battery. So here, this is what it looks like unpacked. Again, it came in as a step file. So when you open the step file, this is what it looks like. And again, this is just for size reference. You're welcome to kind of, again, if you want to be real, keep the battery the exact same size. Do I expect you to keep this port on here? No, I don't. You could literally like extrude cut this away. Again, if you want to be real, maybe you have wires that you sweep to your USB port or something, or at least the PC board. That would make the most sense. But you don't need wires for this project. That's an optional thing. Again, referring back to what I said before, it's up to you to decide how deep into the realism rabbit hole you go. All that I require is that you just have the main components, so like the camera, the PC board, the battery, and then some kind of charging port, because again, to me, that's logical that you would have that. So last but not least, that's the other thing I have in here for you, is the charging port. This one actually was a SolidWorks file to begin with. Sometimes you'll run into the issue where like it was created in the latest version of SolidWorks, but I don't think the 2020 version is out yet. But anyway, here's this USB-C port. So okay, step one, gather your components. Step two, open them, check them out, save them out as SolidWorks parts, okay? And that's kind of what this says here on the sheet. That gets us, again, through step two. Step three is how to create the underlay which you're gonna work within. So what that asks you to do is to create a new assembly. So file new assembly. And then this is all recap from project two, insert component, or I guess it's already brought this up for us. I'm going to start with the camera component because that's the main one. Because it was already centered on the planes, right? This is what you want. You want something centered on their planes or on the origin. I can simply just click the check mark like I did, and it drops it in place. If for some reason the part comes in off center, which happens a lot, especially like sometimes your client is giving you parts that have been made in another program or made in another country and they have a different standard. At this point, you would right click on this and say float, and you would try and find things to align with mates the front plane to. Again, in this instance, the front plane happens to align, so we're good. But you could, for example, you could take this part here, that's probably the center. You can decide where you want this to be, so I could say like, take this line and the top plane. So I'm holding on control so that I'm selecting both of these. And I'm simply going to go ahead and say mates. And then it puts that on there. Maybe I want the front of the PC board to be mated with the front of the front plane. So I can go ahead and say mate there. But then simply we want also the right plane to be centered on the right plane. So this, sometimes what you have to do, like if there's no good place to pick on your part, sometimes you have to open it up, and within here you can simply make a command. You can like make a split line. So I can draw a sketch, I can anchor it to the midpoint. I can go to surfaces here, or no, not, yeah, surfaces, curves, split line, put a split line on my on my PC board. Again, this is what you need to do if it doesn't align. This one happens to align, so you don't need to worry about that, but I just want to show you because if some of you do your own stuff. This gives me a center line here now on the object. So now in the assembly, I can simply take this and mate it to the right plane. Again, holding control to select both of them, clicking on mate, and keeping it coincident. Unfortunately, by adding that split line, it changed the mate here. It's because I split the face that I used to mate to the front plane. So I just simply need to go ahead and reselect this front face and do that. So that's how to center a part onto your planes. And again, eventually where this is going is we are once again going to say this out as a part, and you're going to have a nice package to design around. So the next thing you would want to import is the other components. So in this case, the battery. So here's where I can then go back and navigate to the LiPo battery. It's been saved out as a SolidWorks part. I can open it up. Again, none of this is necessarily new. Sometimes, like, this might not be a flat surface. I don't think it is from memory. So here's where I'm going to use one of these planes. I'm going to try and speed this up because I feel like this is repetitive at this point. But I'm going to go ahead and hit mates. In this instance, I want it to be parallel, not coincident. Just because I want the battery like parallel to this. I'll be honest, I don't know what this thing is on the back of the camera sticking off. I'm assuming this is for like a video input or something. Is that okay? Is that a different kind of port? If you want to use that as a port to the outside of your body, you could do that as in place of the USB-C. I just wasn't sure about it. Okay. So if you want your charging port or cable to be USB micro B, you could do that. Or you could have two. You could have a USB-C and a USB-B. Lots of letters. Yeah, we can learn the alphabet with USB port and stuff. So again, this battery obviously is giant. You could resize it. I give you permission to do that. I would maybe just try and keep the height the same. If we quickly roll back to this thing here, like this is a made-up battery, this blue thing here. I just made it about the right size in terms of thickness. This is another battery standard that you can download. So again, it's up to you to choose what battery you want to use. So this 18350 LiPo, that's this round form factor. That's a very commonly used battery. And for what it's worth, you're welcome to Google and search and find your own battery that fits your needs. I'm giving you a leg up with this one here. And then last but not least, we'll go ahead and insert this USB-C port. And what I would do, again, you would probably get this all centered, mated properly. I won't go through all that detail. You know, like this one, for example, I would probably want to mate to the PC board, or at least make it be parallel to it. Reminder that if you click on this, you flip it, so you can flip that orientation. But again, then what happens is you can see it got a little bit, what's the word, like askew? Yeah. So like the way that I would then fix that is I would go into here, find one of the planes, probably the right one, and go ahead and mate it to the right plane here. One of the suggestions in the sheet, it's not a requirement, but it's a good idea. What you're doing right now, while this step might seem kind of boring or inconsequential, you are kind of laying out the components as you see how you want to design around it. So it might not be a bad idea to like put the USB-C component in twice and put it in facing a different direction so that as you're designing, you can choose where that port goes. But again, for realism, what I would suggest is that you have it, you know, attached to the PC board. You can also resize the PC board as you see fit as well. Just know that the one that's here fits the map that they give you. All right. Okay, so like I mentioned, we are laying out your object and where things go. The question was, how do you know where things go? And that's a really good question because now there's several answers to it. One, you can look at an existing object. That's where it is helpful to have an object you can take apart. Of course, I don't expect that. The way that I put this together logically is it just makes sense for the battery to go behind the PC board in terms of a compact form factor. Another thing you could do, which is done sometimes, you could literally print out full-scale versions of the PC board, the battery, and the USB on a piece of paper, cut it out, and if you want to get really fancy, like glue it to foam core and have the components and play with them and think about a configuration that makes sense to you. For what it's worth, I welcome you all to transform this to how you see fit. The camera does not have to be in the center of the PC board. If you want to like change it so the PC board sits parallel to the direction of the view angle, So that means rotating this black portion of the camera 90 degrees. You're welcome to do that. This is totally fluid and up to you to interpret. If that's like too much information or you're like overwhelmed by that, a configuration similar to this is what I would recommend. And then you can just design around that package. Does that answer your question? So it's kind of open. Like you can look at reference, you can literally print out full scale and play with it as a designer and think about what you think the best configuration is. Or you can pretend like I'm the engineer or the client and I'm saying, you know what, this is the configuration I want, and go with something set up similar to this. Again, I think just in terms of like being logical, I would just remember that the PC board is kind of like, you know, the computer of the unit. So it would make sense for this to be like attached to it. If you, for some reason in your design, want this to be floating off of it, then maybe it could be connected with a wire or something. Again, the wires aren't necessary. So last but not least, once you have it, or sorry, to continue with the question, one last thing. That's where I was saying it might not be a bad idea to like insert another USB-C and put it in a slightly different location. That way you can always suppress or hide one, depending on what your needs end up being. So again, think about this. You know, if you're ever setting up a sketch underlay, this is like the SolidWorks equivalent of setting up a sketch underlay. So let me find a different plane here really quickly. I guess it's the top plane. That's weird. Imagine this is flipped properly and not upside down. But I don't know, maybe it's there. You know, like this way you have two USB-Cs, you can always suppress one. Or you can have one concept where it's facing one direction, one concept where it's facing another. Once you have your components set up, you simply go to File, Save As. This is because things have changed. I don't think it matters, but it's safer to hit Rebuild in those instances. And here, once again, I simply recommend that you go and change this to a part file. And here you might call it like P4 guts. And then I'll open this and show you what it ends up looking like. So now I open up P4 guts. This is what we just created. But this is also the first step to your project. Right? So again, this is your underlay here. It has all of these imported bodies. You'll notice there's a lot of them. In fact, there are 59. Sometimes it's because there's lots. I'm going to assume that each of these are probably their own individual body. So one of the things you could do, so I'll be honest, actually, well, you could, I think for your render, leaving these in, it's going to look really good. You could like combine them. You could suppress them. You could delete them out, right? So that all you have is the main. Because the problem with having all of these bodies in here is it's just going to make it run slow.
So when you suppress it, it's like faster.
Yeah, it'll speed it up. So like.
But if I just like hide it, it wouldn't really difference, right?
It wouldn't make a difference. Suppressing it is better for run speed. So again, it is a problem if it comes in with 59 bodies. You can make it lighter by suppressing some of them. In retrospect now, being aware of this, what I would have done and what I would recommend you all to do is let's go back to our assembly here before you save it out as a part file. If we open up this component here, if you look at like what's visible, so we have the chamfer and we have the mirror. If we put in a delete body command here, we've now simplified this to basically two bodies. You could, if you want, unselect these ones because these are all visible. And to Max's point, you could extrude something so I can replicate. You don't need all the stuff in the back, honestly. So here we've just simplified it from, we cut it at least in half. But now we can even simplify it further by simply creating a quick sketch on this face here, drawing a shape that combines all of these, making an extrude. We don't want to see it though. Firstly, we want to make it incredibly small. And we don't want to see it, so I'm just going to offset it from this face by 0.1. And what we're trying to do here is when we combine the feature scope, we only want to combine it with these ones. So that when we render it, these will all be a different color. And maybe if I'm feeling nice, I'll upload this so you all don't have to do this. So now it's only 3 bodies. And now, so I'm going to go ahead and hit save. So now when I go back to my assembly here, yes, we want you to update. If I now go ahead and file save as, and save it as a part file, and once again, we'll simply just give it a new name so that we can compare the two. So, I mean, this is part, like, again, that bike example I showed you all earlier, I did this. I went through and I got rid of all the bodies I didn't need. I just kept the most pertinent ones. So that is part of the step. And again, if you work with your own files that you download from GrabCAD, you won't have to, but I strongly recommend you go through this process. It will make your life easier. Not only will it make your computer run faster, but it will just make it easier for you to design and build around. So here we go, 17 bodies compared to the 59 before. And what I typically do is then I'll select all these, I'll right click on it, and I'll add it to a new folder, and I'll just call it like reference or underlay or whatever you want to call it, or guts. And now when it simply, again, the way that I would recommend you all work and approach this, it wouldn't hurt to then print this out as orthographic views and then start that as your sketch and sketch around the components. You can then bring the sketch into SolidWorks and trace around it to create your master sketch. That would be like a good workflow. So a recap, so we're off the sheet now at this point. A recap of how you might go about that is this is, again, where you would create a drawing. We haven't done drawings since project 1. So file new drawing. Let the computer think. I typically go ahead and just type in 11 inches by 8.5 inches. We want to drop the guts in here. Front view, top view, or whatever you want, side view, whatever you think is going to help you the most. And you could also like drop in a 3D view if you wanted. I guess this is new to everybody, so I guess pay attention for those of you that are asleep. You can set up a view that you find appealing in SolidWorks. So let's say you want to sketch around this. This is how you would set up a sketch underlay from CAD. Maybe you want to see the ports, so you want to show that section. So maybe you would set it up like this, or better yet, like this, so you see both ports. Turn on perspective, that's by going up here and clicking this, because you're wanting to sketch around it. If you now hit the space bar, you can click on new view, and you can say like underlay, or call it whatever you want, call it under. Click OK. And now it's saved this camera angle. So anytime I spin this around, if I hit spacebar and click on under, it will snap back to this. So that's useful for creating underlays in SolidWorks. The other nice thing is now if I go back to my drawing sheet here, I can say insert drawing view model, get the CAD guts, and now if I scroll down here, under is an option in my views. And I can drop this in here. And now this is a very quick way to make, perspective drawing. And now I have a sketch underlay. And again, hopefully this is useful for other classes. You can change the size. You want to make it bigger. I'm not feeling like doing math. If you recall Des 140, like all the headache in trying to set these up, SolidWorks makes it easy. You could then print this out and now have an underlay that you can sketch over. The nice thing is if you take this step, because you have these guts, whatever sketch you do in the front and side view, you could scan that and trace it to make it your master sketch.